Today I want to describe why engineering often specifies strong backing when you're doing leak repair on a set of flanges. When you have a leaky flange and you're doing a flange clamp style repair, tongue clamp style repair, a wire and peen repair, there's often a need to add structural restraints, also known as strong backing, to the set of flanges to keep the flanges from separating. But why are those required after you install a clamp and they weren't required before? Sometimes they're even required when the studs on the flanges look perfectly fine. So if there's no indication that the studs are going to fail, why would engineering specify that you need strong backing? So I'm going to explain in this video why they are required. So essentially what happens is that when flanges are designed, initially, these studs are designed to take the pressure load inside the pipe. So the pressure inside these flanges is acting outwards and it's trying to pull this joint apart. I'm going to start with describing how the studs are initially specified when a flange is being designed. So this is a simplification. There are some more factors to this, but essentially what the studs need to do is to contain the pressure that is within the gasket surface. So I've got this gasket here. It gets set on the inside of the flange. Assuming that there's no leaks, you could say that the internal pressure of the system goes up to, at the very most, the outside edge of the gasket. If it acts past that, then you've got a leak. When you're designing a flange, they're designed so that all of the force from that internal pressure that's pushing on this surface is contained by these studs. So they need to be strong enough to contain that pressure force. They also need to be sized so that they can apply enough additional force to the gasket joint itself so that there's adequate compression on the gasket. So they need to be strong enough that you can torque them or tension them to get enough force on the gasket that it adequately compresses and seals. So when we add a clamp to a flange set, what ends up happening is that you're going to seat that clamp usually on the outside diameter of the flanges. So it's going to sit on here. You're going to inject sealant into the gap. And what that ends up doing is extending your pressure area from being just the gasket surface all the way up to the outside edge of the flange. So now we've got sealant all in here, filling all your stud holes. And so there's the potential that the pressure inside the system could act all the way to the outside edge of the flange. This area in here is actually quite small relative to the additional area that you add when you put a clamp on here. There is an argument to be made that the sealant, when it's filling up this gap, actually seals at the outside diameter of the raised face or the gasket surface. The problem is that we can't actually guarantee that. There's no way of us knowing where the pressure inside the flange begins and ends once you have sealant inside there. So what we do is we assume the worst case scenario, which is that your internal pressure goes right from the ID here all the way to the outside diameter. In some circumstances, there are flanges where the studs in the initial design are actually strong enough, if they're in good condition, to contain that extra pressure, and you don't need to add strong backs. But in a scenario where we've got this additional pressure area and those studs do not have enough strength to contain the extra pressure, then that's where strong backs are required. There are a couple things that you can do if you want to avoid strong backing. Strong backing can be expensive. It can make the clamp very big or the overall repair very big. So there's an option that you can look at doing a hot bolting procedure and replacing the initial studs that were in the flange with some higher strength studs. We have done that before. If that is possible where you can do hot bolting, that is a good option. So in a nutshell, that's why strong backing is often required. when you're doing a flange repair. If you have any additional questions, feel free to reach out to us about this, and we'd love to give you some more information. Flanges are one of the most common sources of leakage in industrial plants, and ensuring that they are flat and in good condition has always been time-consuming and difficult, until now. Introducing Flange Vision, software developed by My Engineering that dramatically reduces flange inspection time and complexity using 3D scanning technology. Simply import your 3D scan data, select the inspection surfaces, and within seconds, Flange Vision automatically generates circumferential and radial flatness results. These results are all compared directly to ASME PCC1 standards and compiled in an easy-to-read report. No more complicated dial indicator setups, no more specialized probing equipment. Just scan, inspect, and export. For more information or to arrange a demonstration of Flange Vision, please contact My Engineering at info@myeng.ca. That's info@myeng.ca. Flange Vision, the future of flange inspections.